Okay, this is the answer key to your homework from page 105. Not going to go through 1 through 4 because you're supposed to use the definition there. So if you have any questions about those, we can go over them in class. But number 5, I told you not to use the definition of derivative for 5 through 12. So hopefully you use the rules. And what it's really important for you to understand on this one is that you could either use the quotient rule, or you could recognize that x on the bottom is really x to the negative 1. And this trick is going to show up a lot. It's much easier to take the derivative of x to the negative 1 because you would just multiply negative 1 by 1 and subtract 1 from the exponent. And then hopefully you would recognize that that's really negative 1 over x squared. And when you plug in the 2, that's where the negative 1/4 comes from. But let's say you didn't recognize that. Then you do the quotient rule. Low d high, so x times derivative of 1, which is 0, so I'm just going to write 0, minus high d low, well that's derivative of the bottom is 1, so 1 times 1, all over low low. So again, you have negative 1 over x squared, and when you plug in 2, you get negative 1/4. Either of those ways works. Number 6 is x squared plus 4. This is the sum rule, so you just take the derivative of this, which is 2x, and the derivative of 4 is 0. To evaluate it at 1, you just plug in 1 for x, and you get that the derivative at that point is 2. Aren't derivatives fun? This one is very common too. You have to recognize that this really means x plus 1 to the 1/2. That's what it means to have a square root. So it's just the power rule. 1/2 times x plus 1 to the negative 1/2. Or in other words, 1 over 2 times the square root of x plus 1. And plug in 3. 3 plus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. The answer is 1/4. The next one, the derivative of 2x plus 3 is simply 2. Because the derivative of 2x is 2 and the derivative of 3 is 0. At a equals negative 1, it's still 2. And think about why that is. Remember, the derivative is the slope of the tangent. So if we're looking at a line with a slope of 2, the slope of any tangent to that line anywhere is going to be 2. It's a constant. All right. Find f prime of x. That's just another way of saying the derivative. So this would be 3. Again, it's a line. Derivative of a line is a constant. This is another fancy way of saying take the derivative. If y equals 7x, find the derivative of y with respect to x. That would just be 7. And this is another way of saying take the derivative, d dx of x squared. And that would be 2x. So those are all the ways you could possibly see taking the derivative. Number 12 was d dx of f of x if f of x equals 3x squared. So basically take the derivative of this, which is 6x. That's your answer. Now I don't have my document camera working, so I'm going to talk you through 13 through 16. Match the graph of the function with the graph of its derivative. So the derivatives are a, b, c, and d, and the functions are 13, 14, 15, and 16. So I want you to look at your book right now and look at number 13. You can see that the derivative as you move along the left-hand side is negative. So we're looking for a derivative over here that's negative. And it's negative going from something really steep to something less steep. So it's getting less and less negative until the origin where it's 0. And then it's getting more and more and more positive. So we're looking at choice B because, and also you can tell it's a parabola, which is an x squared, and the derivative of an x squared is an x. But that's how you would think about that. 14, again, you can tell that it's a cubic, and the derivative of a cubic would be a quadratic, so I know it's A. 15, I'm not really sure about that, so let's think about it. As I move from the left, the derivative changes from positive to negative. This is really, really, really important. Look at number 15. On the far left-hand hump, the derivative goes from positive, an uphill tangent, to a downhill tangent. So when you move over to the left and you try to find a derivative, you're looking for something that changes from positive to negative. Now remember, when you cross the x-axis, that's when a function goes from positive to negative or negative to positive. So it crosses from positive to negative. Choice D is your answer, because it goes from positive to negative, and then it changes again at the bottom hump from negative back to positive. Okay, so 15 is D, and then if you look at 16, the function is negative, 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 0, and then positive, positive, until the origin again where it's 0 again. So that would be choice C. All right, on to number 17. It says if f of 2 is 3, so that means the value of the function at 2 is 3, and f prime of 2 is 5. That's the derivative, so the slope of the tangent at x equals 2, the slope is 5. So if we want to write the equation of the tangent line, okay, so we want to find the equation of the tangent line. So we're going to do y minus 3, because that's the y value when x is 2, equals the slope, which is 5, times x minus 2. There's your equation. The equation of the normal line would just be y minus 3 equals negative 1/5 times x minus 2. Just flip the slope and make it negative. Now it doesn't tell you that your answer has to be in slope, intercept, or point slope. So these answers are fine, but these don't match what the book says. Don't freak out. Just recognize that either slope, intercept, or point slope is fine. Number 18. Find the function is y equals 2x squared minus 13x plus 5. And you need an equation of the tangent at x equals 3. Well, let's find the slope of the tangent. The slope of the tangent is, oh, we get to hear Dr. Sparrow, 4x minus 13. At x equals 3, plug in 3.
Students who did not have their picture taken yesterday.
Negative 1.
I need you to come down.
So I'm going to plug in 3
to get your pictures taken.
for x.
Also, faculty members who still need to have their picture taken.
Minus 39.
If you need coverage or need someone to step in while you get your
5.
picture taken, please call 602.
Negative 16.
Thank you.
So our equation is going to be y plus 16 equals negative 1 times x minus 3. That is the equation of the tangent line. Uh-oh, that's not what this says. Oh wait, maybe it is. Negative x. So if I distribute this, I get positive 3 minus 16, negative 13. That's right. Okay, 19. Tangent and normal. So the function is y equals x cubed. So the derivative is 3x squared. I could also write that as y prime is 3x squared. And I want to find it at the point 1, 1. So the tangent line would be y minus 1 equals, plug in 1, you get 3 times x minus 1. And the normal would be the same point again with a negative reciprocal slope. Why do they have 1/4? Oh, that's the wrong question. 19, we're good. And find the lines that are tangent to the curve at square root of x. This is number 20. Square root of x. Well, that's really x to the 1/2, and the derivative of that is 1/2 x to the negative 1/2. Or in other words, 1 over 2 root x. And we want it at the point x equals 4. So, first I need my y value for my function, so I plug in 4 there and I get 2. So the point is 4, 2. So I have y minus 2 equals, plug in 4 here and I get 1/4 times x minus 4. That is it. And then the normal is just a positive 4. And we can talk about some of the pictures in class, but that's a general idea of how you should be doing derivatives.